Class example 4.44. For each of the following rational functions, state the non-permissible values, describe the effect on the graph of the non-permissible values. So is it a vertical asymptote or a point of discontinuity? State the domain and state the range, and then label these characteristics on the grid and use your graphing calculator to help sketch. Okay, so first thing we're going to want to do is factor. So let's rewrite this as f of x is equal to, and this would be x plus 5 times x plus 2 over, and then x plus 5. All right, so now the non-permissible values. Well, we have a non-permissible value at x is equal to 5. Oh, negative 5 rather. So we'll say x cannot equal negative 5. So what's the effect of this? Well, this is one of those non-permissible values where it cancels. So in that case, this is going to be a point of discontinuity. So sometimes POD or PD. The domain, so we've kind of stated that already. The domain would be x such that x cannot equal negative 5. Now for the range, it might be helpful to sketch our graph first, just so we can kind of picture what's happening with the range here. So if we sketch our graph, we get a straight line, and this makes sense. We could have sketched this without actually graphing it, where if we simplified the expression above, then we would have had f of x is equal to, and then we'd just be left with x plus 2. This really is the line x plus 2. We cross the y-axis at 2, and we have a slope of 1. Now the difference here is that we have a point of discontinuity, and that point of discontinuity happens right at negative 5. So that makes sense. That was our hole. We weren't allowed to have a point at negative 5. So now if we're going to figure out our range in this case, well, our range just can't be, well, I can see right here, it can't be negative 3. I can see that from the graph, but we could also determine that algebraically. So let's do that. So with the simplified expression, f of x is equal to x plus 2. So we'll say, just write that again, f of x is equal to x plus 2. What we're going to do here is we're going to sub in the non-permissible value, so negative 5. So we'll say f of negative 5 is equal to negative 5 plus 2. So f of negative 5 is equal to negative 3. So there you go. Our range value cannot be negative 3. So this point of discontinuity would be at negative 5, comma, negative 3. So we just need to exclude that y value from our range now. So we'll say for our range, y such that y cannot equal negative 3. Okay, let's take a look at b. So we have g of x is equal to x plus 2 over 2x squared plus x minus 6. All right, so just like last time, let's factor this. This is one of those more difficult ones where we're going to have to deal with this leading coefficient that is not equal to 1. So let's factor this first. So this is 2x squared plus x minus 6. So if you remember on these ones, we have to find numbers that multiply to 2 times negative 6. So we're looking for numbers that multiply to negative 12 and add to 1. Right, just the number 8 there. All right, so numbers that do this, that must be 4 and 3, and they need to multiply to a negative number. So 1 has to be negative and 1 has to be positive. Looks to me like the 4 has to be positive and the 3 has to be negative. So now we'll rewrite this middle term with the 4 and the negative 3. So 2x squared plus 4x minus 3x minus 6. And then we'll factor by grouping. So factoring out these first two, we get 2x, and then we have x plus 2. And then for the second two, we're going to factor out a negative 3, so now we'll have minus 3, and then x plus 2. So our factors here are x plus 2 times 2x minus 3. Okay, so that was factoring the bottom, and now let's just write it all again. So now we have g of x is equal to x plus 2 over x plus 2 times 2x minus 3. Okay, so from here, let's take a look at our non-permissible values. So in this case, we can say that x cannot equal negative 2. And from this factor, we'll say that x cannot equal 3 over 2. Just setting that equal to 0 and solving for x there. Okay, so these are our non-permissible values. Maybe we'll write them again up here. So x cannot equal negative 2, and x cannot equal 3 over 2. So now the effect, we have a vertical asymptote, or VA, at, well, where did this one happen? Well, the one that doesn't cancel, so that's the 3 over 2, at x is equal to 3 over 2. And we have a point of discontinuity, so either POD or PD, at x is equal to negative 2. And that's from the factor that does cancel. Okay, so the domain. So the domain here would be x such that x cannot equal negative 2 or 3 over 2. All right, so before we do the range again, let's kind of put this all together. I think we can sketch this even without graphing it probably. So we have a vertical asymptote at x is equal to 3 over 2 or 1.5. So we could sketch that in. And then the general function there, so the general shape of that would have been, well, this would have simplified down to g of x is equal to, and then if we cancel the x plus 2's, it would have looked like this. It would have been a 1 over 2x minus 3. So that's just going to be a graph that's shifted from the origin over 3 over 2 to the right, because that's our new asymptote. And then we also just know that we have a hole at x is equal to negative 2. We were expecting that. But now we don't really know what the y value associated with that one would be. So let's solve for that. All right, so how do we solve for that? Well, we take the simplified version that we just created, and then we plug in the non-permissible value. We see, okay, when x is negative 2, what is y there? So we'll say, what is g of negative 2? So 1 over 2 times negative 2 minus 3. So we'll say g of negative 2 is equal to negative 1 over 7. All right, and that kind of makes sense. That's about right. So now let's write down the point there. So this point would have been at negative 2, comma, negative 1 over 7. So that kind of helps when we're figuring out our range here. All right, so careful with the range though, because it's not only going to be that negative 1 over 7. We also have to think about our horizontal asymptote. It's also not allowed to be that horizontal asymptote. So we'll have 2 of them. So our range would be y such that y cannot equal 0 for the horizontal asymptote or negative 1 over 7.